Hello, welcome to my YouTube channel. Today I will solve my Sudoku puzzle called Outside the Box. It is an original puzzle. The rules are relatively simple. Normal Sudoku rules apply. That means that in every row, every column, and every 3x3 box, the digits 1 through 9 appear once each. Second rule is that digits on a thermometer increase away from the bulb end. So this circular gray part is the bulb. That is the lowest digit on a thermometer. Let's say it's a 1. This digit can be a 2, 3, 4, or 5, or 6, or 7. And this digit can be a 9. No other digit can be a 9 except for on the tip. No other digit on the thermometer can be a 1 except the one on the bulb. And every number as you go away from the bulb has to be higher than the last. Third, a digit in a circle indicates the number of circles that contains that digit. So what that means is that there is a 1, let's say there's a 1 in a circle. There is no other 1 in any circle in the entire puzzle. Let's say there is a 2 in one of the circles. There is one other 2 somewhere in the puzzle in a circle, and there are no 2s besides those 2 in circles. If there is a 4 in a circle, there will be 3 other circles that have the number 4 in them, but only 3 others will have the number 4, and the rest of the circles will have different numbers in them. So that's the basic rules. Then there's a rule that I added, which is that every one of these boxes has a center digit, and the center digit of each box is equal to the sum. I get that. Allow me to tap more than once, select more than one at a time. Okay, the sum, the green digit in the center of each box is the sum of all the circled digits outside the box that are adjacent to the box. So this green cell in the center of box 1 is the sum of the 2 circled cells outside that box. This green sum is the sum of these 2 circled cells, and you notice how one of them is diagonal. When I say adjacent to the box, I include the diagonals. This center of this box happens to only have 1 circled number outside it, and this is going to come back in the puzzle. I probably shouldn't have given that away during the stating of the rules, because solvers are supposed to find that. But those are the rules. Please, if you want to try the puzzle, pause the video, go try the puzzle, and come on back and give me a comment whether you thought the puzzle was fun or boring and hard or easy, or if you happen to make it through my description of the logic. Please let me know if you think there's an easier way to get some of the places that I go quicker and more directly. So let's begin the puzzle. First thing that we see about this puzzle is that there are 4 circles in 4 digits in circles around the center box. Those 4 circles contains the numbers 1, 2, 3, and 4. They can't contain a 5, because if there was a 5, there could be a 5 and a 1, and then there couldn't be another 1. There could only, in circles, there could only be a 5, a 1, and 2 2s, and those add up to 10. So 5s are out, 1 through 4 it is, and the numbers in those circles are either 1, 2, 2, 3, which adds to 8, and I only want that in the center box, in the center of the box here. That adds to 8, or 1, 2, 2, 4, or 1, 2, 3, 3, and those each add to 9. So those are the possibilities. There's always a 1, there's always a 2, sometimes there's a second 2, and sometimes there's, or in one of the instances there would be 2 3s, but there will be a 1 and a 2 circled. So we know that at least 2 of the numbers that we have in circles in this puzzle are 1 and 2. The next thing we notice about this, and I'm going to color these, let's see. I'm going to color these bright yellow. I can remember where they are. Next thing we notice is that there are 11 other circles in the digit. There's 15 total. We know that in a circle sum puzzle that the number of circles equals the sum of all the numbers that are in circles. If you think about it for a minute, that makes sense. Anyway, these circles contain the numbers 2, 3, 4, and 5. I know that because there's only one way to get to 15 that also allows us to get to 8 or 9 with these yellow. To get to 15, we can do 1, 2, 3, 4, and 5. Those numbers add to 15. Another way we could do it with a 1 and a 2 would be to go 1, 2, 5, 7. And as I said, as I explained earlier, we can't get to the single-digit number in these yellow cells with 1, 2, and 5. So it has to be 1, 2, 3, and 4, and 5 in the circled cells in this puzzle. Okay, we now solve, or we discover that these two cells, this cell that I'm circling it right now so you can see the one I'm talking about. That yellow cell cannot be a 1. Why? Because it is the same as that cell. And I'm going to put the 1, 2, 3, 4 in there, and then we're going to look at that. That cannot have a 1 in it because it is on a thermometer. And it's not in the bulb of the thermometer. And as I said, if there is a 1 on the thermometer, it has to be in the bulb. So that's a 2, 3, 4. This is a 2, 3, 4. This is a 1, 2, 3 because it has to be lower than the 2, 3, 4. The same is true down here. This is a 2, 3, 4. And this number is a 2, 3, 4. So we know we have a 1 on this, in one of these 4 yellow cells. And before we go directly to that, I'm going to say that this has to be a 5, and these two have to be a 2 and a 3. Why? Because the lowest they can be is a 2 and a 3, and the highest that can be is a 5. So these are the 2 and 3, and this is a 5. This, in the same column, there is not a 2 and 3. In the same box and in the same row, there's not a 5. Now, this cell in box 3, the center of box 3, again, I'm circling it so you can look where I'm looking. That cell is the sum of 3. Okay, wait, I have to get rid of this 1 first. This cell cannot be a 1. Why can't it be a 1? Well, if this were a 1, this would not be a 1. This number would sum with that number over here in this green cell to be a 3, 4, or 5. And now look, we have 1, 2, 3, 4, 5 cells in this box. We have 5 cells that all have to have the number 2, 3, 4, and 5 in them. That's only 4 numbers for 5 cells. That breaks the Sudoku rule. This is not the 1. This one is the 1. Now, we know that these are at least 2 and 3 because they are not the same number. This number is the same as that number. This number is different from that number, therefore this number is different from that number. I'm going to make this one, I'm just going to get rid of the yellow in there. I'm going to put yellow over here, get rid of that green. And then I'm going to make this red. Just so the red and yellow, we know they're different. Now the least they can be is 5. The most this can be, therefore, is a 4. Otherwise, this number would be greater than 9. It would be a 2-digit number, not allowed in Sudoku. So, now we have a 2, 3, 4 triple in that row. I'll make that purple. And we have a 2, 3 pair over here. So 2, 3, 4 triple and a 2, 3 pair. There are no other 2s anywhere in the Sudoku puzzle, in circles. So I'm going to go through and take all the other circles. I'm going to take out the 2s. And once I do that, now I've got a 3, 4 pair. All in these, the purple cells now have all the 2s and all the 3s. So we can go back to those outside circles and take out the 3s. Now we have 2, 3, 4, and 5. All right. That gives us, I don't know how this got marked. Oh, that's marked from my whole 1 exercise. Anyway, it is a sum of 3 and 4. We don't know which of these is 3 and which is 4, but we know that that is a 7 because it is the sum by the outside sum rule. Take that marking out of the color out of there. This one is the sum of these two. It's a 4 and 5. Well, the 5 is the bigger one. The 5 goes there, the 4 goes there. 4 plus 1 equals 5. This one is 1 plus 4 or 1 plus 5, so it's 5 or 6, but it's not 5 because it's in a row with a 5. So it is a 6, and that is a 5. Now, in this cell sees 1, 2, 3, 4, 5, 6, and 7. It is an 8 or 9. This cell is the sum of 2, 3, and 4 in some combination. It is, well, what could it be? 2, 3, 3 would be 8. It's an 8 or a 9. That gives us a 1, 2, 3, 4 quadruple in that column. The 4 is not down here. It is up here. To be clear, there's a 4 in box 9 already, so that the 4 in the column has to be up in box 3. Okay, now we have, this is a 5 because it's in a box with a 4. And now we have 1, 2, 3, 4 of the 5s found, and we have 1, 2, 3 of the 4s found. There's only 1 4 and 1 5 left, and they are here. And what's interesting about that is that they are not the same. One of them is a 4 and the other one is a 5. I'm going to mark one of them a dark red. I like that color. The other one I'm going to mark a dark blue. I'm going to get rid of all these other blues, the blue color in these others. We get rid of all this pink. We'll hang on to these for a little bit because they're different numbers. In this spot, okay, first we have to solve this 1. There's a 1 there. Oh, this is annoying. Okay, this is not a 4 because it's in a column with a 4. Now I need to get the 1 in there before I do the next thing I'm going to do. Anyway, this is a 6, 7, 8, or 9. This digit is a 1, 2, 3. This digit is 3, 4, 5, 6, 7. It's not a 4. How did I get rid of that 4 before? Oh, yeah, of course. Can this number be a 4? If this number were a 4, both of these numbers outside here, all of these, the digits in the circles surrounding box 2 would be 4, 2, 1, 2 for a total of 9. So if this is a 4, This is a 2 and that's a 2, and then both of these cells become 3. So this is not a 4. It is a 3. That is a 2 because it's in the same box with the 3. That's a 1, has to be lower than the 2. This is a 2, it's in the same, it is the same as the sum in the center of that box, and they are, that by the sum rule, they are the same. Take the shading out of that 3, but make this one a 4. 2, 3, 2, 3, we'll solve that in a bit. Now that allows me to say this sees 1, 2, 3, 4, and 5. It is 6, 7, 8, and 9. Because remember, these are a 4 and a 5. We don't know which is which. That cell sees them both. Now there's no longer any 3 here. This is not a 1. That's a 1, 2, a 2, 4. This is a 5, 6, or 7. This is a 6, 7, 8. And this is a 7, 8, or 9. So the only place for a 5 in this column is there. That's a 5. Now we have 6, 7, 8, 9, 6, 7, 8, 9. We have 6, 7, 8, 9, 4 of them. We have a 1 and a 2. The rest of the row is a 3, 4, 5. This one here sees a 5 in the row. It sees a 4 in the box. That's a 3. That's not a 3. That is a 4, and it is that dark 4. And I'm going to undo, let's see, this, 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 and this. I'm going to take the green out of those. I'll get rid of that 4 or 5. I don't need that 4 or 5. I just need the other one. I need those red ones marked so we remember they're the same. That's going to come in really handy at the end of this puzzle. Okay, so we have, this is not a 2 or a 3, it is a 4. Now we have a 4, 2, 3, adding up to 9. 9, and we have an 8 in that column. We have, this is the 3, sees that cell, that's the 3. That's going to resolve our 2, 3 pair in column 4. We have a 6, 9 pair over here. This cell is a sum of 3, 2, 1, and 3, total of 9. That makes this the 6 and this the 9. I'm going to undo my yellows. We don't need those anymore. And I'm going to get rid of the sums that I've found. Oh, by the way, this is a 3, because it's the same as that. Those are both 3. And now I can just get rid of my 4 and my 5s. Just take those colors out. We don't need them. And all but one of my center cells are solved. This, by the way, is a 3 in the row. This is now an 8 or a 9. But it's not a 9. It is, no. It's a 7 or an 8. Caught myself in time there. That is not a 9. This is not a 9. So this cannot be an 8. It's a 6 or a 7. This is a 7 or an 8. Because it's not a 6. That's a 7, 8 pair, making this one a 6. 7, 8 pair in the box, that is. Get rid of this 6. This one is a 7 or an 8, and this one is a 1 or a 2. 1 or 2 cannot go on the thermometer above a 5. This 3, this 1, 2, oh no, I can't do it yet. Gonna need some more work. Okay, this is a 1 or 2. There is a 2 in column 6 down in this box, and it can't be, because there's a 1 there, a 2 has to be at the bulb of this thermometer. There is no number lower in the column than a 2, so it has to be there. That makes this the 1. This cell up here now, which is lower than 4 or 5, is a 1, 2, or 3, but it's not a 1 or a 3. It is a 2. This has to be the 3 because there's a 4 or 5 in the box, and it has to be lower than them both. Takes the 3 out of here. Well, that 3 has been gone for a while. That 3 in the row sees that one. A 1, 2 pair makes this the 3. Okay, this 1, 2 sees that cell because there's a 1 here and a 1 there. So that's the 1. The 1 in this column is there. The 3 in this column is there. Now we have, this is a 7, 8 and an 8, 9. This 7, 8 because it sees 1, 2, 3, 4, 5, and 6 in the box and in the row. So that's the 7, 8, that's an 8, 9. And now I'm going to color 7 and 8s because this is going to solve us to the next part of the puzzle. Make that one yellow, that one pink, this one in the column with the pink is a yellow, in the row with the yellow is a pink. This yellow cannot be in that row. It has to be in this column somewhere. It can only be there. That is the yellow. This is the pink. This is the yellow. This pink has to be in this box somewhere, and it can't be in the center column because that's all taken. So the pink is here, and that makes this one a 9. And that's a very good, helpful digit because that becomes a 9. Now we have 9s. We can hold our screen a bit. Got a 9 there. Got a 9 up there. Got a 9 somewhere in there. We got a 9 here. So the 9s are there and they're all taken. I like to color them gray once I've found a certain digit. So we'll do that. I'm going to try the 3s next, see if I can get all those. 1, 2, 3, 4, 5, 6, 7, 8, 9. They are all taken. How about the 1s? Well, there's not a 1 there because it's on a thermometer way above, way toward the tip. That's got to be the 1 there, and there's a 1 here. No, it's not there. My bad. Put a 1 here. No, 1. No, that's not. I'm really having a hard time with that 1. There it goes. These 2 ones, look into that box. Now, let's see. Do I have all my 1s? I need a 1 there and a 1 here. Gives me all my 1s. Mark those gray. Now I can do the 2s. Give me a 2. There's a 2. 2, 2, 2, 2, 2, 2, 2, like there. This one sees that one. Those are the 2s. Okay, mark those gray. Now we've got an interesting problem here. We need some 4s in these columns. And there's 2 cells up here that are a 4 or 5 pair. They are either 4s or 5s. Now what happens if these would be 5s? If those were 5s, where do we put 4s in the row? This would be a 4, so this wouldn't be a 4. There's a 4 in that row. There's a 4 in that box. This can't be a 4 because it's on a thermometer above that 3. And if we had a 4 in this cell here, what would go between the 3 and the 4 on the thermometer? There's no cell that would do it. So either the red ones are 4s or these 2 down here are 4s. And these are on the row together. The 2 cells at the top of the columns are the 4s. These are not the 4s because they're, like I say, in a row together. That 4 plus 3 makes 7. The yellows are 7. The pinks are 8. And from here, we should be able to make relatively quick work of the entire Sudoku. That's a 4. 4, 4, 4, 4, 4. There's a 4 there. There's a 4 here or here. Okay, yeah, it's not 4s I can do right away, but I do know there's a 4 there. What about 5s? Can I do the 5s now? 5 up here, 5 in that row, 5 in this column, 5, 5, 5, and the 5s are done. Let's try the 6s. I think they might go. No, I'm not really, those are not helping me as much. Well, 7s go. I need a 7 there. I need a 7 here. I need a 7 in that, there and here. Is that my 7s? I believe those are my 7s. And my 8s, can I finish off 8s while I'm at it? 8, 8, 8, 8. No, the 8s aren't quite fallen for me yet. Try those 6s. 6 there, 6 here, 6 there. 6 can't be below 5 on a thermometer. 6 there, 6 here, 6 here, and 6 there. Those are the 6s. Mark those gray. I should already have the 7s done. 8s. 8, 8, 8, 8. And what is 4, 4, 4? And this is the 8. And I'm done. It's solved. Puzzle is correct. I did it in 25 minutes today while explaining it. I would still like to be as fast as Mark Goodliff on Cracking the Cryptic. If you haven't checked out Cracking the Cryptic, I highly recommend it. I love that channel. I love watching all the Sudokus that come out. They recently published one of my puzzles, and I hope to submit this puzzle as well. So please let me know what you think of it. And thanks very much for watching. Bye.